Hey boys and girls, it's Mrs. Barberry from Berry School. For math today, we're looking at Unit 5, Module 4, Session 5, which is adding areas. Our learning targets today. Today we'll use models so we can recognize area as additive. We will know we are successful when we find areas of rectangles by separating them into smaller rectangles and adding the areas of the parts. Here's some of our academic vocabulary we're looking at. What do you think? What does area mean? What is an array? We can use the pictures to guide our thinking. Well, an array is an arrangement consisting of equal rows and equal columns. Area. I'm using my pictures as a clue for what do I think area is. Area is the total number of square units needed to cover a two-dimensional surface. Our materials we need. For this lesson, you will need a pencil or a pen. Normally in math class, we only use pencils, but since we're at home, I know pens might be easier to find. So either one is fine. So you need a pencil or a pen and a piece of paper or some sticky notes. See the pause button right here? That's reminding me that you can now pause the video to go get your materials. I'll wait right here. Go ahead. Welcome back, everyone. All right, I have my sticky note and my pencil. I'm ready to go. Our investigation. Let's investigate this tile rectangle over here using our colored tiles and our red linear pieces. All right, class, you're up. I would like you to write down at least 3 things you know about area using this tile rectangle. So what are 3 things you can tell us about this rectangle? You can use the color tiles, the red linear tiles. I see a pencil here, so I know I'm going to need my materials and my pause sign. So I'd like you to pause the video now to write down your 3 things. Go ahead. Welcome back, class. All right. I would like you to share your ideas with someone about what you know about area. It can be a family member. It could be a stuffed animal or a pet. I'd like you to pause the video and share out your thinking now. Welcome back. All right, let's see if your notes compare or connect to my notes. I wrote down that there are 4 equal rows. Do you have a connection? Also, I noticed there are 6 tiles in each row. The area is 24 square units. When I use area, we label it with square units. To find the area, I could do one of 3 things. 1, I can count the tiles. 2, I can add. I can add 6 plus 6 plus 6 plus, you guessed it, 6 equals 24 square units. Or I can multiply 4 times 6, which equals 24 square units. Now we're going to predict and investigate the results of separating our tile rectangle into 2 smaller rectangles. Will the total area of the 2 smaller rectangles be the same as the area of the original rectangle? Or will it change? Why? All right, I see my pencil material, my pencil picture, and my pause icon, so I know to get my pencil or pen and paper ready. You're going to write down the answer to this question. Will the total area of these two smaller rectangles, when I add them together, are they going to be the same as the original rectangle, or will it change? Write down your thoughts and pause the video now. Welcome back. What do you think? If I take this original rectangle and I cut it right over here into two smaller rectangles, when I find the area of the first one, the area of the second one, and add them together, is it going to be 24 square units the same? Or is it going to change? The area is going to be the same. It's still going to be 24 square units. This is called the distributive property. But how can I prove it? You know, as mathematicians, we're always trying to prove our math thinking. Well, I have my original rectangle. I'm cutting it into two smaller rectangles. I'm going to find the area of this first one. I see 4 rows times 4 in each row is 16. I'm going to jot that down and hold on to it. I'm going to go on to my second rectangle, my smaller one. I still see 4 rows of 2. So 4 times 2. 4 times 2 is 8. Now I'm going to take the area of the first smaller rectangle and add it to the area of the second rectangle. 16 plus 8. I know 16 plus 4 equals 20. And then from 20, if I add another 4, that's 24 square units. And 24 square units equals 24 square units. It's the same. Let's learn more about the distributive property. Before we do, distributive is a hard word to say. Let's practice saying it slowly. You're going to repeat after me, slow like a tortoise. Ready? Dis, trib, u, tiv. Slowly, repeat after me. Dis, trib, u, tiv. Now repeat after me, fast like a jackrabbit. Distributive. Distributive. All right, let's listen and learn more about the distributive property. You may have to turn your volume up, although I'm going to turn my volume up too, so hopefully that helps. It's about 5 minutes. Sit back and enjoy.
In this lesson, you are going to learn how to use the distributive property by using area models. You already know that when we multiply whole numbers, we are combining equal groups. You also know we can use an area model to help us show and solve multiplication problems. For example, if we have the problem 8 times 7, it means we have 8 groups of 7. We can show this by using an area model that is 8 rows with 7 square units in each row. We can find the product to 8 times 7 by counting the total number of square units inside the rectangle. We see that there are 56 total square units inside our rectangle. So the product of 8 times 7 is 56. I'm going to show you how we can use the distributive property by using area models. Let's take our same area model for 8 times 7. If we want, we can make this into an easier problem with smaller numbers. We can break apart the 7 into 5 plus 2, since 5 plus 2 is 7. Now we can think of our problem as 8 times 5 plus 2. We can show this on our area model by breaking it into 2 smaller rectangles. Our first rectangle will still have 8 rows, but there will be 5 square units in each row. Our second rectangle will also have 8 rows, but there will be 2 square units in each row. We can solve this by finding how many total square units are in each rectangle. So we know that 8 rows of 5, or 8 times 5, gives us 40, and 8 rows of 2, or 8 times 2, gives us 16. Now, since we broke apart our rectangle into two smaller pieces, we need to combine them by adding them. So we know that 40 plus 16 will give us a sum of 56. That means 8 times 5 plus 2 equals 56. Notice this is the same answer we got when we multiplied 8 times 7. 8 times 7 is equivalent, or the same, as 8 times 5 plus 2, because both of these problems will result in the same answer. When we multiply both the 5 and the 2 by the 8, we call this the distributive property because we are distributing or multiplying both numbers in our parentheses by the 8. The distributive property says that whenever we have a problem, like 4 times 3 plus 2, we can multiply both numbers that are inside the parentheses by the number that's outside the parentheses. So 4 times 3 plus 2 means we have 4 rows of 3, or 4 times 3, and 4 rows of 2, or 4 times 2. We know that if we multiply 4 times 3, we get 12, and 4 times 2 gives us 8. Together, that gives us a sum of 20. Since the distributive property works with any whole number, we say A times B plus C is the same as A times B plus A times C. Let's see how this works in a problem. Mark wants to buy 3 notebooks that cost $6 each and 3 pens that cost $4 each. How much money will it cost him to buy the notebooks and pens? Since we know that Mark...
If you want to pause, I paused the video for you, but if you want to pause the big video, you can jot down and think and try to solve. How much money will it cost him to buy the notebooks and the pens?
Has to pay $6 for each notebook and $4 for each pen. We can use the addition problem, $6 plus $4, to represent how much he will pay for 1 notebook and 1 pen. But we also know Mark isn't buying just 1 notebook and pen. He's buying 3 notebooks and 3 pens, which means he will have to pay 3 groups of 6 plus 4, or 3 times 6 plus 4.
What is 6 plus 4? Right, 10. What is 3 times 10? 30. Let's see if when we add up 3 times 6 and 3 times 4, if that equals the same. Let's see.
We can use what we know about the distributive property to help us solve this problem. We know that 3 times 6 plus 4 actually means we have 3 groups of 6, or 3 times 6, which we know is 18, plus 3 groups of 4, or 3 times 4, which we know is 12. To find the total amount Mark will pay, we need to combine these 2 answers to get a sum of $30. This shows us that Mark will have to pay $30 for both the notebooks and the pens. By using the distributive property, we were able to solve our problem. In this lesson, you learned how to use the distributive property by using area models.
All right. Now, we're going to play a game. It's the Area Shape game on Shepherd Software. ShepherdSoftware.com is one of my favorite educational websites. There's a lot of math games you can play, as well as other topics too. So it looks like this. We're going to practice your area skills. There's no turn-in assignment today. There's just material. Let's play the game. So you go to shepherdsoftware.com and click this link, or it's also in your Google Classroom. On Shepherd Software, there's usually an ad going down on the side, and on the bottom, we don't click on ads. They just want money. We don't want to give them any. So here's the area shape game. I'm going to press start. Area is the number of square units needed to cover a figure. Example, this figure has 3 squares, so the area is 3 square units. This rectangle's area is 12 square feet because 2 feet times 6 feet equals 12 square feet. Let's start. Round 1 says, click the shapes with an area of 4 square units. Let's look at our first choice. 1, 2, 3, 4. Yeah, that has 4 square units. Let's look at our next one. 1, 2, 3, 4. I'm going to click on it. Next, 1, 2, 3, 4. 1, 2, 3, 4. Yep. Let's see. 1, 2, 3, 4, 5. Nope, I'm not going to click that one. 1, 2, 3. Nope. So it must be this one. I got them all. And I click next, and then you would go on for the next couple of rounds. And that's how you play the area shape game. After you play the area shape game, I'd like you to just play around with the partial product finder. Cool thing about it is, for example, I have 4 times 6 as one big rectangle. I can split it into 2 smaller rectangles like we did in our lesson. And you can see that the area is still going to be 24 square units. So this is just a fun resource you can use to play around with. All right. And that's it, class. I hope you enjoyed your math lesson today. Thank you for listening. Hope you all have a great day. Be kind to each other. Bye.